Thank you, sir. So I'm going to be presenting on this paper on how to build your own artificial intelligence software for free to diagnose retinal fundus photographs. So mind you, the problem statement which we try to solve here is to differentiate between different retinal diseases, which is an easier solution than grading diabetic retinopathy. But this is just a proof of concept. We have no financial interest in this presentation. We use free software to make that. Firstly, ophthalmology has a lot of imaging and measurable big data, which is ideal for application of artificial intelligence. And AI has been used for detection of diabetic retinopathy, glaucoma, ARMD, retinopathy of prematurity, retinal vascular occlusions, other retinal diseases, in addition to keratoconus, measuring, calculating IOL power, and several other parts of ophthalmology. And AI is considered complex, expensive, and out of reach for most people. So we propose to create an AI algorithm using free online tools. So it was to develop an AI algorithm that can detect retinal diseases from fundus photographs and evaluate. We used the software Teachable Machine by Google, and we did it as an observational study. We had a less number, that is 58 fundus photographs of ARMD, BRAO, CRVO, macular hole, retinitis pigmentosa, subhyaloid hemorrhage from data, and this was almost equal in number. One image from each category was randomly set aside for testing, and this teachable machine software was trained using the remaining 52 images. We tried with an epoch of 50, that is how long the training goes on for, and also 500. This was completed quickly, but then accuracy was not sufficient. After increasing the number of epochs to 5,000, and it took 5 hours for the software to process and develop the algorithm, we did this testing. The testing images were used, and the ones with 50 and 500 epochs did show some sensitivity, but it was very less, 20 to 40% confidence in detecting the disease. So we trained with 500 epochs, and it showed a recognition in confidence of 80 to 95% for identifying the disease. So the teachable machine platform is a very low cost, effective method for creating an artificial intelligence algorithm. This image shows some of the test data. These are all subhyaloid hemorrhages, and this is the testing images. So these are the images we use for checking the algorithm. This is the teachable machine interface. We group the images into various categories. If you see here, there are 9 images in all the categories: BRAO, CRVO, macular hole, retinitis pigmentosa, subhyaloid hemorrhage. We adjust the settings here and train the model, and once the model is trained, it allows us to test it. And the most common use of AI in ophthalmology is fundus images to detect diabetic retinopathy, and the FDA has approved IDX-DR for this purpose, for detecting referable DR. And typically it requires more computer processing power, so it is uploaded online to a server, which is not always possible in places like India, and in large scale screening in rural areas where it is most needed. There was a study which showed an offline AI by Medios AI, which is on the Remedio Fundazon phone from Bangalore, which showed a high sensitivity and specificity for using this. Teachable machine allowed the creation of a simple AI at actually zero cost. So this is again the interface, and this is the preview window. Here we load an image, and then it detects what of these diseases it is. It is able to detect this image as a CRVO with 100% accuracy. This model can be exported to a website on Google servers, or you can export it onto a Raspberry Pi or any other computer of your own, and then it can use image upload to detect the disease and tell you. So the limitations of our study is a small number of images. We use only 58 images for both training and testing, but and also there is a resolution limitation with the free teachable machine, and it is also not capable of highlighting hotspots to show what part of the image resulted in the diagnosis. So that is the black box problem of AI. These are my references. Thank you.
So what are the alternative softwares? Are there any other better
Absolutely, sir.
softwares?
So if you want to use a commercial AI, in fact, the Medio's AI is pretty good. It is on the Remedio Fundazon phone cameras, no commercial interest. There is a free version which can be accessed through the Orbis Orbis International's website. Just go to cybersite.orbis.org. If you register as an ophthalmologist, you can upload your own fundus photographs to the site. It will run it through their AI.
And what I meant was for creation of your own.
For creation of AI, you can, if you know programming, you can actually use Google TensorFlow and actually code the whole thing. This is a very basic interface where you can just give the images and let the algorithm decide what are the differences. If you want to code it yourself, you will have to know a little more advanced AI concepts, which is you have to do programming basically.
So would you just tested out 58 images, right?
Yes, sir.
So if suppose it was say 5800 images or 20,000, would the things
I suppose
change?
the accuracy would increase much more even with this software. This
it will
software
accept so many large numbers eventually?
it has some limit, but I think it is 1,000 or so.
Okay.
So I've used 58 because that is the only number of images which I could easily get. If we had a larger database, we could definitely go up to 1,000 per set, I believe.
Okay. And is there any issue with data privacy in the sense,
So,
you may have amongst those 58, you could have had some VIP.
So these are all anonymized data. There is no patient information at all. So there was no privacy issues with this data.
Thank you.
Thank you, sir.
Thank you, John.